Okay, in question 3, we are looking first of all at the name of the distribution to describe when the spinner is spun once. Okay, it's spun once. So key thing here is we have got 5 possible outcomes. Each outcome has equal probability of occurring. So we've got a uniform distribution. Moreover, it is a discrete uniform distribution. It can take the values 1, 2, 3, 4 or 5, and each of those has a 1/5 chance of occurring. The graph of it, the distribution would look like that. Next part, the spinner is now spun 28 times. The random variable x represents the number of times it lands on 2. So here the probability that it lands on 2 is equal to 1/5. And we are in the binomial distribution now. We have, it's spun 28 times. Now, I have 4 conditions for the binomial. The first is that there are a fixed number of trials, n, or here there are 28 trials. The second is that there are 2 possible outcomes. Here it lands on 2 or it doesn't. The third condition is that there is a fixed probability of success. Well, here that is 1/5. And the fourth condition is that the trials are independent of each other. So we are definitely in this distribution. Okay, part 1. The probability it lands onto at least 7 times. Start off by translating that into this kind of statement. We're looking for the probability that x is greater than or equal to 7. Now remember that the binomial distribution, when we're looking at cumulative, it's always less than or equal. So we have to translate this statement into this. If it's greater than or equal to 7, it's everything take away the probability that it is less than or equal to 6. This will leave me all of the probabilities for it landing 7, 8, 9, 10, all the way up to 28 times. To get this on your calculator now, just to find this probability here, we're in binomial cumulative distribution. Because we know the 6 there, we're going to go with variable, not list, and we can just type in x is 6, n is 28, p is 1/5, and it will give us that value 0.6784. 1 minus that is 0.3216. That's the answer to part 1. Coming on to part 2. Looking at that statement there, we need to translate that into this. If I'm looking for x greater than or equal to 4 and less than 8, here are some numbers, 1 to 8, and it would go on up to 28 possible outcomes. What I'm looking for it being 4, 5, 6 or 7 effectively. So I want it, the probability that x is less than or equal to 7, which would be all of those, minus that it's less than or equal to 3, and that will leave me behind the ones that I'm looking for. Again, at this point for each of these, we are in binomial cumulative distribution. This time I'm going to go variable x is 7, n is 28, p is 1/5 to get my first number there, and then variable x is 3, n is 28, p is 1/5 to get that answer there, and then that's my final answer.